Welcome everyone, thanks for joining. Today we'll be talking about bridging the gap between Jenkins and Kubernetes. We'll try to understand what makes Jenkins suitable in a cloud native environment like Kubernetes. I would like to tell you more what kind of additional plugins, components, configuration is required to run Jenkins effectively in Kubernetes environment. On the other hand, I believe there are many different solutions for the same problem. So I'm more than happy to hear your story, your challenges you faced in the past when running Jenkins. And more importantly, feel free to challenge me and tell us that something could be done better. This presentation is mostly based on our own experiences when building Jenkins Kubernetes Operator for over 2 years now. And that's pretty much it. Let's start. A few words about me. I'm Bartek Antoniak. I work at VirtusLab as Cloud Engineering Manager. I'm mainly responsible for internal product initiatives, uh, partnerships, open source projects, as well as I help customers with cloud transformation or digital transformation processes. Feel free to find me on Twitter, and again, please engage into conversation. Cool. Let's bridge the gap. As mentioned, today I would like to minimize the gap between Jenkins and Kubernetes, uh, give you an overview what needs to be done to run Jenkins in a cloud native way. As some of you probably know, Jenkins itself is quite dated technology, not necessarily designed to be run in such a dynamic environment like Kubernetes. However, nothing is stopping us from making this fully operational with a little bit of extra work at the end of the day. And that's the main topic of this presentation. But before we get started, it's really important to have a common understanding of the definition of cloud native environment. Depending on number of people you're gonna ask about definition of cloud native, I'm pretty sure you will have slightly different answers. That's why let's have a look at cloud native computing foundation definition and use this as a good starting point for the rest of presentation. Cloud native technologies empower organizations to build and run scalable applications. And these applications are running in modern dynamic environments, in public cloud, private cloud, even hybrid cloud is becoming a trend these days. However, for me personally, the key aspects of cloud native ecosystem are containers, service mesh, which helps with inter-service communication, especially with a large number of loosely coupled microservices, and immutable infrastructure together with declarative API or declarative configuration as code, which helps a lot when it comes to automation of some processes. And these techniques enable loosely coupled services uh, to be basically, it enables dev teams to build and deploy resilient software, which is easy to manage and fully observable. And of course, the process is end-to-end automated. We can deploy changes frequently using predictable workflows with minimal operational toil. So that's the definition of cloud native environment. And now if we look at the old model of running Jenkins versus the new cloud native model, according to the previous definition, we have some key elements here, like empower. We want to free up our engineering teams from operational work and let them focus on something more relevant than constant troubleshooting, deploying new Jenkins instances every day. Then scalable and dynamic. We want to transform from fixed to fully dynamic agent pool. We want to be elastic when it comes to on-demand agents. We want to consume pay-as-you-go model which cloud provider brings. We want to avoid resource waste. And also we want to be able to scale in a moment of overload. Speaking of resiliency, eventually we need to change our ways of working from manual troubleshooting to Kubernetes self-healing mechanism. So we want to write software, we want to write automation, which is fault tolerant and take an advantage of self-healing capabilities provided by the underlying platform, which is Kubernetes in our case. Manageable, from manual deployment to configuration as code. We want to have one single source of truth when it comes to configuration. All changes needs to be driven by code, a version in Git. This basically helps to maintain predictable workflows, have a good discipline, and scale our teams to basically manage more Jenkins instances or any other services as part of our infrastructure. Observable, from logs to events and traces. We want to understand how the system behaves. We want to know what's happening, what went wrong, what was the problem before it will be a serious incident. And last but not least, robust automation. We want to automate the manual deployment and use Kubernetes resources. So use all these capabilities which are already built in the platform instead of writing our own automation layer on top of that. Then it's also really important subject to understand what's the definition of cloud native readiness in terms of Jenkins. So what makes Jenkins cloud native ready in our opinion? So declarative configuration as code, that's probably one of the most important elements here, because we want to automate as much as possible. We want to scale our teams. We want to handle and manage more services in production. Without good level of automation, that's almost impossible. Security by default, it should be day one activity. I would even say security should be a default. We should provide a sensible defaults as part of the initial deployment process. Software we deploy should be already handled, already basically configured properly. In terms of full lifecycle management, we want to automate the process of deployment, upgrades, disaster recovery. That's something we usually do manually. These days, with the technology on the market, can be quite easily automated, which I will be talking about on the next slides. Authentication and authorization, that's a really important element of as part of security also. We need to have fine-grained access control model within our organization. And also we want to have the same authentication and authorization model for all services as part of the infrastructure, of course, if possible. Observability, logs and events, Kubernetes brings a lot of value in this field already. External storage, we need to be able to do backups, store them externally, and restore them at any point in time if we really need to. And this finally brings us to native integration with Kubernetes. We want to leverage Kubernetes API and couple Jenkins as tightly as possible with Kubernetes. Before we jump into all these elements, I would like to discuss the core mechanism of extending Jenkins or configuring Jenkins. As you already know, Jenkins is really modular, and entire configuration and extension is based on plugin ecosystem, which is really rich. You can find more than 1,500 plugin on the market. Of course, it adds some security risk. Jenkins has its own history in this field. However, that's the core mechanism of extending Jenkins together with declarative configuration as code. So Groovy scripts are basically main entry point to the Jenkins API. With the actual programming language, we can configure low-level properties of Jenkins and directly execute Groovy code. Or also we can invoke some methods remotely if we really need to, but this is not recommended. And there is a really interesting mechanism called init scripts. So all Groovy scripts which are located in Jenkins home init groovyd are executed automatically during the Jenkins startup process in alphanumerical order. So that's the core mechanism of initial configuration of Jenkins. On top of that, we have configuration as code plugin, which brings additional abstraction layer on top of Groovy scripts. That's a YAML-based configuration, so it's human readable, slightly easier compared to Groovy scripts. You have a lot of predefined tasks, so go-to solution should be configuration as code with less overhead. On the other hand, if you want to have full control and configure some low-level properties, use Groovy. Additionally, DSO job plugin lets you configure pipelines as code and manage builds programmatically. So if we look deeper at this diagram, it shows an overview of entire pipeline as code workflow. On the left-hand side, we have the definition of pipeline with the actual pipeline below with some automation logic. Everything is versioned in Git repository. It's often called seed jobs repository, acting as a single source of truth when it comes to jobs, when it comes to configuration files. So we have everything in a single place. And Jenkins, using DSO job plugins, automatically picks up these files from Git repository and configure jobs accordingly. For additional security, we can use SSH keys to authenticate Jenkins against GitHub API. So that might be helpful if you have GitHub Enterprise or private repositories. On the right-hand side, Jenkins create and update pipelines. So every time you modify the pipeline code in Git repository and trigger a new build, Jenkins will automatically reconfigure this pipeline and use upstream changes. So that's a really nice mechanism how you can automate pipelines. Moving on to full lifecycle management. In terms of Jenkins, it usually involves initial configuration, installing, upgrading Jenkins, installing, upgrading plugins, which is quite problematic sometimes, especially in terms of dependency, how managing different versions. So it's always good to have a kind of automation here. Of course, monitoring, and this leads us to constant reconciliation process. What does it mean? Thanks to operator framework, which provides such a capability to automatically reconcile the actual state of Jenkins, which is the snapshot of the service, including configuration, running jobs, everything which has been configured. And on the other hand, we have desired state. Desired state, that's a receipt basically we provided, and operator will make sure the actual state reflects desired state constantly. So every time we modify the actual state manually using Web UI or REST API, operator will override such changes according to desired state defined as part of configuration as code repository. If we look deeper at operator framework, it basically this diagram outlines 5 different capability levels. The first level is just a basic install. So if we want to render initial configuration, deploy something, how might be useful. The second level is seamless. Is about seamless upgrades, so patching, bumping some components. But finally, the level number 3 is a good place to be. I would say it's good enough to provide a really really good value for the team and reduce number of operational activities. And it's called full lifecycle, including application lifecycle, storage lifecycle, backups, and some disaster recovery mechanism as well. Of course, if you want to go beyond that, that's also possible. It adds a lot of complexity, but I think it's worth the effort. Especially if you're developing an operator, you should aim for autopilot at the end. But let's go back to the level number 4, which is deep insights. So this usually involves metrics and alerting mechanisms together with some analytical flow. And the end goal is autopilot with horizontal and vertical auto scaling, some automatic tuning or scheduling depending on capacity of your underlying platform. And below we have 3 different technologies to implement operator. Helm, super simple. I would say it's good enough for a basic install, maybe seamless upgrades, but definitely not full lifecycle management. Ansible is more like a configuration management tool. And then finally, Golang is actual programming language. So you have really good flexibility here. You can implement any business flow you want. You can use some external libraries, SDKs, clients. You can implement end-to-end tests. So countless number of possibilities out there, and that should be go-to position. Speaking of authentication and authorization, Jenkins by default gives you username and password authentication, which is a good starting point. Not production ready, definitely. And if you already use some identity providers within your organization, whether it's Active Directory, one login, or something else. It's always good to have the same authentication flow for all services as part of your infrastructure. I would recommend looking at GitHub Authentication plugin, which is based on OAuth. We can maintain everything in a single place, including configuration as code, including pipelines as code, as well as authentication configuration. And also some other some 2.0 identity providers are also supported if you want to. When it comes to authorization part, Matrix authorization plugin gives you many options to configure fine-grained access control, and it also supports configuration as code, so should be fairly straightforward to at least to build an initial version of your authorization strategy. Security is one of the most important aspects in Jenkins. Especially Jenkins has its own history, mainly related to plugin ecosystem. A lot of vulnerabilities, a lot of deprecated protocols. So it's really important to take a look at Jenkins recommendation, which is quite detailed, and follow these steps and make sure we addressed all these problems one by one. Additionally, configure Kubernetes airbag model. Make sure you have good namespace level isolation. You use specific set of Kubernetes APIs instead of giving one big cluster role. It's especially important if your Kubernetes is a multi-tenant environment. If you have more than one teams maintaining their own workloads, their own CI/CD services, you need to provide a kind of isolation mechanism and secure Jenkins by default. In terms of backup and external storage, Jenkins state should be embryonic. Basically, what does it mean? That every time we change something manually using Web UI, using REST API, it will be overwritten um, by operator by automation during the restart process. So we should have a good discipline of configuring everything from code, versioning in Git as a single source of truth, and not doing any manual changes. Otherwise, we'll end up with a big um, snowflake instance of Jenkins, which is really hard to recover, and we can barely touch it. In terms of backups, we want to backup jobs and build artifacts only. We don't want to backup these heavy XML files because they are already part of configuration as code. And why jobs and artifacts? Because we want to have visibility what happened. We want to take a look at past test results, things like that. And it's really important to use external storage for storing backups to limit the blast radius in case of disaster. You can use S3, Blob, depending on your use case. In terms of restore, we highly recommend to run restore on the startup process, which is one of the very first activities before Jenkins is fully operational. It can be done either using init scripts written in Groovy or using Kubernetes sidecar pattern. I think sidecar pattern is better option because you can separate the lifecycle of Jenkins itself with the backup restore flow. So you have these two processes running in parallel. In terms of logs, events, and observability in general, I think Kubernetes brings all of that out of the box. Of course, you can take a look at Prometheus metrics. You can install Node Exporter or look at some additional Jenkins plugins with Prometheus compatible metrics. This finally brings us to native integration with Kubernetes. We want to use Kubernetes to run Jenkins jobs. But in order to do that, we need to install Jenkins Kubernetes plugin, which runs dynamic agents in a Kubernetes cluster. So every time we trigger a build, it creates a Kubernetes pod for each agent, which consists of different number of containers depending how your job looks like. And these are short-living pods. So do the job and everything will be terminated by Kubernetes. It uses JNLP to automatically connect to the Jenkins controller to maintain connectivity. And again, define fine rate access airbag model in Kubernetes namespace. Make sure you follow least privilege principle here. Okay, and finally, it's worth mentioning our project called Jenkins Operator. This is something which we were working on for over 2 years now, and we want to solve a problem of running Jenkins in Kubernetes in a really nice and automated fashion. So Jenkins Operator takes care of lifecycle management of Jenkins. It also provides some additional configuration options, like pipelines as code, like everything what we discussed so far. It's part of the Jenkins operator itself. So definitely worth to take a look and give a try. And that's the final snapshot of everything what we discussed today. That's the picture of Jenkins in Kubernetes environment. On the left-hand side, we have a namespace with operator, which provides best practices and initial configuration. So by default, we provide sensible defaults. We provide some base plugins, everything which makes Jenkins fully operational and secure. On the other hand, user can provide his own configuration like plugins, Groovy scripts, configuration as code, and many more. The operator controls lifecycle of Jenkins. So on the right-hand side, we have a separate namespace with Jenkins and all additional components. So Jenkins is running backup sidecar container, which uses external storage for storing backups, restoring them when Jenkins starts. And also there is a persistent volume for some persistent state if needed. Service on top of that with type internal. This is intentional because you shouldn't expose Jenkins over the public internet. We've heard the stories about script console exposed with admin rights. That's a huge security threat for your entire infrastructure. So use DMZ, either Bastion or VPN or any other tunneling technology, depending of your network architecture. In terms of configuration, both for authentication, authorization, and pipelines, use Git. That's the very nice platform. And Kubernetes plugin takes care of ad hoc provisioning of Jenkins jobs. It's worth to take a look at the agent on top, which is a kind of specific agent called seed job agent. This agent is responsible for running any system processes like executing Groovy scripts, configuration as code, some other installing plugins. We want to separate these two and make sure we have a dedicated sandbox environment to run these sensitive operations. And we have more user-defined agents depending on your configuration in Git. It can consist of various different containers. It will always have JNOP in place to provide communication between Jenkins controller and agent. If you are interested in more cloud native capabilities and managed version of Jenkins Operator, take a look at Operator service for Jenkins. It brings more interesting options, and again, it's managed service. I want to leave you with the following conclusion, that at the end of the day, we should free up our engineering teams, whatever that means. We should solve business problems and do it with more efficient engineering. So if we can develop a software which will automate some processes, especially within a dev tooling space, that can bring a significant improvement and significant reduction of operational costs for your organization. And that's pretty much all. Please connect on LinkedIn, Twitter, engage into conversation, provide feedback if you find it useful. Maybe you could do something in a different way, or you face some problems which we didn't cover today. More than happy to continue this discussion, either using Q&A or offline. So thank you very much again. And I think it's time for some questions.